radial equation of hydrogen like atom. So let me write radial equation. So radial equation, as we have done in previous class, if you can remember, it is like dr of r square dr minus 2m r square h cut square, and there will be vr minus energy into r and equals to l into l plus 1 r. Fine. So let us first replace r as like equation r into r, like that, function of r. So that implies r equal will be r, right? So let us replace that one. So first let us find out first derivative and second derivative. So only first derivative. Okay, so dr by dr will be u by r, right? So that will be for fixed r, and this is du dr, right? Good. And later fixed u and r will be r. Fine. And divided by r square, you know it. Fine. So then let us find this thing, ddr of r square dr. So let us find that thing so that the things will be easier. Okay, so if I directly write, if you can verify it, I have done previously, so I can remember it. Okay, so if you can solve this one, you will find this thing. Now replace these two terms there, and so replacing the terms, you will get, sorry, h cut square, okay, just plus, okay, so v plus h cut square. So you can remember it, if you recall center force equation, then you will do some similarity. So in this way you can remember this equation. This is something like center force equation. Fine. So now you can understand this is similar to V effective potential, right? So we have to solve this equation. Now you know, since it is a we have written potential as V only, but as the problem is known to us, because we are dealing with the hydrogen like atom. So it is well known that the well known form of the potential of hydrogen like atom. So if I write that potential, you know it. I think you know it. 1 by r. Already in class 2 level we have read all those things. The form of the potential of hydrogen atom. Sorry. Extremely sorry. Okay. So now if I write this in the equation, we will get so this is something like so plus just replace this one and just end again there like this. Okay, so l into l plus 1, right? So we have another written one, square, it is u and equals to u. Fine. Now solution. Suppose we know in previous problems already we know that somehow we have to simplify the equation and then we can solve it easily. Now to solve this equation, so first let us define a new constant. Suppose it is small k. Okay, so I am defining small k to me by h cut. Fine. If I write this one, now one thing you have to see here, if solution or the problem is for the bound states, then here e have to be negative so that k is real, right? Otherwise it will be imaginary number, right? So for that e have to be negative for bound states. So uh, okay, so now if we suppose do that thing to replace or simplify the equation, suppose I will replace the thing by, here see, here is E, right? E. And now if I write the equation in a simplified form, look at the equation. If I suppose write what's the U, right? E U and okay, k square, suppose it is a k square, so minus 2me by h cut. Fine. So let me write in this way 2m e. Now you can see this something similar thing here, d to u dr square. If you do k square, then you will find minus 2me by h cut square, something like that, plus so okay, let me write this thing. So I have divided e by e, right? So simply 4 pi epsilon 0 e, right? Fine, plus h cut square 2me. See, there is also the center, l plus 1. Okay, so it is u. Okay, now you replace this 2me by h cut square as k square. So you will get fine. So you will get, suppose if I write k square. Okay, so it will be k square. This one k square and d2u by dr square. Fine. Okay, and one thing will be u. First, let me write the whole thing. And then it is plus, okay, plus e square by 4 pi epsilon 0 here. E square by 4 pi epsilon 0 er, like that, I think. Yes. And minus, because that was a plus, minus that was l into l into l plus 1. This is k square and another one is r square, right? And equals to u, and there was nothing. Okay, fine. So if I bring this term into that side, so what will happen? And also there is, suppose e. So somehow I have to replace all the e's term. Okay, so there is e. If I put e as this equation, or that minus 8 cut square k by h cut square k square by minus 2m, so we will get, so I am bringing this term and putting the value of e here, right? So I will get d2u dr square, right? Bringing this term that side. Suppose I will take u common, so there will be 1, right? And first I am writing this term, this will get minus. Okay, now if we put the thing, I will get, suppose okay, there is m term, m e square, okay, and there is the 2me term, so 2e m 2me will, and there will give 2 pi epsilon will be there, and other thing will be h cut square, actually k square, okay, r. Fine. This will be plus l into l plus 1, and already this was like that. Okay, now this is u. Fine. Okay, so kr. Okay, so now let us define another parameter, like defined as so let us consider, okay, another parameter rho kr. Here is a kr term, so we will replace rho equals to kr. Fine. Now and also you have to other thing, if you put kr there, and you have to define this term as a constant, this rho 0. Suppose this is rho 0, and this have to be defined as AB square 2570 h square k. So you will take kr as rho. Fine. So this is rho 0. So rho 0 by rho. So if I replace this thing as by rho, so I will get a simplified form, more simplified form. Okay, so this is there is a k square. Okay, so here you are considering that thing, and okay, you are, let me write. Okay, just a minute. Oh, sorry. So you have to find out this thing too. Sorry. So let us find du by suppose 0. Okay. So or it is 0. So you can write du by dr and into dr by so d rho. So dr by d rho you have to write, and again so if you put the thing here, so you will get du by dr into it will be dr by d rho, right? So 1 by k square, sorry k, only k. Now if you d2 rho by d rho square, simply you can understand you will get just k square, right? du by dr, very simple thing. Sorry, dr square here. Okay, so now you replace the thing. Suppose so du by d rho, it is the d rho square, d2 rho by d rho square equals to 1 minus rho 0 by rho plus n into n plus 1 by and this is rho square. Okay, just be careful when you will replace. So now like we have done in the previous problems, that we have found out the two asymptotic solution of the equation by varying thing, I mean the variable at the infinity and also at 0. That is tending to asymptotic means is tending to something. So tending to infinity and tending to 0. We will now find out the solution of this differential equation. So first let us think. So for rho tending to infinity. So rho tending to infinity, so you can easily understand. So this two term will blow up and we will be left with only d2q by d rho square equals to q, right? Simple. This is very simple. So the solution, you know, if I write it is something rho minus 1. Fine. So now if you put rho equal to infinity, so one thing will be plus. So rho infinity, you can understand this term will go up. So we will left with only if rho into infinity, then we will left with only a term. Now in the second part we will discuss the rho at. So rho at, so for rho tending to 0. So rho tending to 0, the equation we will be left with tending to 0, because it is the only big term. We will left with 1, u will not be there because it is negligible with respect to this. We consider only rho term, rho square, so it is a big term, big term. You can understand this thing. Okay, so fine. So for that we will not solve, just we write the solution. We have done several times perhaps. Solution. So we gives like that solution. So here also if you put n equals to 0, so for L equals to 0. That term will blow up, right? Okay, because it is 1 by rho to the power L, sorry, L naught, it is for rho, we have to consider rho, that's why it's not coming. Oh, sorry, rho tending to 0. So rho tending to 0, so that term will blow up because 1 by rho term. No. So we'll be left with only, fine. So C rho L plus 1, fine. So if we combine these two equations to deal the asymptotic, two asymptotic behavior precisely, one is at infinite, and one is at 0. So if we try to deal the thing, we have to consider. So okay, let me write. So to deal the aforesaid okay asymptotic behavior we will consider u rho as combining the two. So if I write rho n plus 1, it is for tending to 0, and e to the power minus 1 for tending to infinity, and let us define another variable v rho, suppose. So for your information, I want to inform you that I have followed the Griffith quantum mechanics. So you will find all those calculations there. So there is no problem. You want to know more descriptive form, so you can follow that book. Fine. So okay, now simply we will replace that thing in the equation. So for that we have to calculate du by do first. So this is like that. P, so dp by d, this is P. Okay. So fine. And again, if we calculate d rho square, then we get fine. Now if we replace the term, we will get actually now one thing. Okay, let us replace the thing actually. So after replacing, I will get, you will get, and replacing and simplifying, you will get d2v, okay, d rho square plus 2 n plus 1 root minus rho dp d rho, okay, fine, plus rho 0 minus 2